All right, everybody, how we doing? Again, like I mentioned in class earlier today, we're going to be talking solubility, right? We're kind of be moving away from discussing everything there is to be about concentration, and we're going to talk solubility for the next couple of days here. A portion of today and then tomorrow's video will really help you guys out, especially with those of us that are kind of struggling through the current lab right now, the lab on solubility. All right, so the information in this presentation here and in this video, as well as the next video for tomorrow, is definitely going to help you out with that. I know I mentioned that in class to a few of you. So let's talk solubility, okay? So plain and simple, solubility is the measurement of how much solute can dissolve in a given amount of solvent, right? Because that is a thing, all right? You can't just continue to add Gatorade powder to your liquid water, right, indefinitely. Eventually, it's going to happen where you're adding too much powder that your water can dissolve. And that's where solubility comes into play, right? It tells you how much your solvent, in this case water, how much solvent can essentially dissolve your powder, okay? Now, there's three different types of saturation, right, in terms of solubility, right? If something is very, very low in saturation, there's not a whole lot of solute dissolved into your water, that's when you have what's called an unsaturated solution. So an unsaturated solution is a solution that contains less solute than could possibly dissolve in that particular solvent, right? So that's the example I gave the other day, where if you just pour like a little bit, just a small, like little, maybe like a teaspoon of Gatorade powder into your water bottle, right? That's not a whole lot of solute you're putting and dissolving into your water. So because of that, there's so little solute in your solvent, you've got an unsaturated solution. Okay, it's not saturated with the maximum amount of solute that can be put into your solvent. Now, on the other hand, something called a saturated solution is when a solution contains the maximum amount of solute that could possibly dissolve in that solvent, right? So that's why there's a certain amount of powder in your Gatorade pouch, right? When you go to pour that in your water, because they know exactly how much powder can dissolve into a roughly 12 ounces to 12 fluid ounces of water. So they put just enough in there to have all of that powder get fully dissolved into that particular amount of water, 12 fluid ounces of water. Right, that's when a saturated solution, right, when it contains the maximum amount of solute that could possibly dissolve. Now, in some special cases, you can run into a situation where you've got what's known as a super saturated solution. And that is a solution that contains more than the maximum possible amount of solute that could possibly dissolve. Now, there are several different ways that you can achieve a supersaturated solution, right? One that contains more than the maximum, and we're going to talk about that in just a second here. So, factors affecting solubility, right? There are several different things, and we're going to talk about a few of them right now that affect how soluble or not a substance is. With the first one being on, on surface area, right? So plain and simple, solubility is how well something dissolves, right? If it has really high solubility, that's because it dissolves very easily in water. If it has very, very low solubility, that's because it doesn't dissolve very easily in water. Now, surface area, right? Surface area affects solubility in the sense that the more surface area for a solute to exist on that particular solute, the more soluble that substance is going to be, right? So if your substance has a very high surface area, it's going to dissolve and have a higher solubility. It's going to dissolve easier and have a higher solubility on your solute. Okay. Second here is temperature. Temperature is going to affect solubility, right? So if you have a higher temperature, that's going to indicate that particles are in greater motion, right? Because as we know, temperature is the measurement of the average kinetic energy. And as we know, kinetic energy is the energy of motion. So if you have a higher temperature, that means you have a higher motion in your particles. So if you have a higher or greater motion in your particles, you're therefore able to come into contact and dissolve more readily in your solvent. Okay, so the higher the temperature, the more your particles are moving, and the more those particles are moving, the more they're going to come in contact with the solvent, and that's going to allow them to dissolve way better and have a higher solubility. And three, the nature of the solvent or the solute. Okay, and this is where the idea of polarity comes back into play, right? We talked about polarity a number of times already this school year, right? So if you have two different substances, your solute and your solvent, and both are polar, polar will dissolve polar. Now on the flip side, if you've got your two different substances, your solute and your solvent, and both are nonpolar, well, that's also good. Nonpolar substances will dissolve in nonpolar substances. On the flip side though, okay, if you've got opposites, if you have a polar solute and a nonpolar solvent, that's not going to fly. Okay, those things are not going to dissolve into each other. Okay, so this phrase of like dissolves like is really important because it drives home that idea that only a polar substance can dissolve a polar substance and only a nonpolar substance can dissolve a nonpolar substance. Okay, otherwise, nonpolar will not dissolve polar and polar will not dissolve in nonpolar, right? They have to be the same. Like dissolves like. And lastly, we're going to talk about something known as the solubility curve, which is table G. That's going to be the basis of what we're going to, mostly spend our time on in class tomorrow. Table G here, okay? It looks kind of similar to a couple of the graphs and tables we've utilized already in the past, but table G has a couple of components to it. First and foremost, I always like to go over the ins and outs of the graph itself, right? The title of this curve, or the title of this table is called Solubility Curves at Standard Pressure. So we know that standard pressure is 1 atmosphere. We've got an x-axis here, which is temperature, so and it's all measured in degrees Celsius. And then we've got a solubility as our y-axis, and this is in grams divided by 100 grams of H2O. So everything here on the y-axis here, you guys, like let's say, for example, if I pick out 50, for example, that means that I've got 50 grams of a substance for every 100 grams of H2O. Right, that's what this last bit here means, divided by 100 grams of H2O. Okay, so whatever measurement you've got here on the y-axis, that is referring to the amount of grams of that substance in 100 grams of H2O. Okay, so for example, if I had 50 grams of, I don't know, KNO3, 50 grams of KNO3 is going to be, hey, I'm dissolving 50 grams of KNO3, potassium nitrate, into 100 grams of water. And what is the solubility of that when I do that? Okay, so it's all based on your number of grams of that substance in 100 grams of water. Okay, now, whenever you're plotting these points here, right, because it's all about plotting a point of temperature and solubility. Okay, when you plot a point on this graph here, there's a couple of things you have to look out for. Whether that point is either below, on, or above any given line here. Okay, and that's where we get into this idea of utilizing those vocabulary words from before of unsaturated, saturated, and supersaturated solutions. Okay, so for example, let's say I was given 50 let's say 50 grams. Okay, 50 grams of KNO3 at a temperature of, we'll say, 50 degrees Celsius. Okay, 50 degrees Celsius. You have to then go and trace, right? Let's plot this on the graph here, right? So here's 50 degrees Celsius. Here's 50 grams on the y-axis. If I trace up and across, okay, oops, no, I don't want to do that. If I trace up, this is my plot here, right? My plot is very clearly right here. Well, here's my curve for KNO3, right? It's this guy right here. This is the curve for KNO3. All right, and I'm kind of messing up that curve at the end there. Let me make that a little bit better. This is rough looking. Nope, not the highlighter. I want the eraser. All right, there we go. Okay, so let's try again. Here's the end of this curve here. Okay, so here's the curve, right? My dot is very clearly right here, and it's below, right? We are below the line. You're below the line for KNO3. If we're below the line, guys, that means that we currently have a solution that is unsaturated, a KNO3, a potassium nitrate solution that is unsaturated. It does not have the maximum amount, right? So if you plot a point on this graph relative to whatever the curve is you're talking about, so we're talking about the KNO3 curve here that I have in orange, if your dot is below the line for your curve, It's an unsaturated solution. Okay, unsaturated. Now let's change things up. Okay, let's say, for example, let me grab my eraser here. Grab this guy. Okay, let's change the temperature, for example. Okay, let's change the temperature. So we're still 50 grams. We're still dissolving 50 grams of potassium nitrate into 100 grams of water. But let's do that at 20 degrees Celsius instead. So here's my 20 down here. So at 20 degrees Celsius. Okay, so now let's do the same thing. Let's trace up from 20 and over 50. So here's 20 over to 50, and here's my dot right now. Okay, as you guys can see, this dot is very clearly above our curve for KNO3. Again, our curve for KNO3 is this orange line here. Okay, our dot for KNO3 is very clearly above our curve for potassium nitrate. So since we are above a given line, this is indicating that our solution of 50 grams of potassium nitrate at 20 degrees Celsius is a super saturated solution. So that's your identifier. If your dot is above your curve or above your line, that is a super saturated solution. Below the line, unsaturated. Above the line, super saturated. Well, what happens if we're right on the line, for example? So let's change things up a little bit. Okay, get rid of that. Get rid of our dot. Let's say we are just about here at 30, we'll call it 32 degrees Celsius. So I'll remove the 20 from here, erase that. Okay, let's say we're at 32 degrees Celsius. So let's do the same thing. Okay, let's trace up. 32 is just about right here. Let's trace up and up and up and up until we hit 50. And now we're right here. Okay, our dot is very clearly right on the line. So we now have a plotted point right on our curve for potassium nitrate, for KNO3. If you plot a point, it's right on the line for whatever curve you're referring to. Again, in this case, it's KNO3. We have a point plotted right on the line. That means on the line is a saturated solution. Okay, so if you plot a point on the line, you've got what's known as a saturated solution. So again, here we go. Here's the stretch here, right? Start out below the line. If you have a solution that you have a plotted point on your graph that's below the line, below the curve, unsaturated. So below the curve, unsaturated. On the line or on the curve is saturated. Above that line or above that curve is unsaturated. Okay, so below unsaturated, sorry, I just said unsaturated. I meant supersaturated. So let me say this again. Okay, below the line, unsaturated. On the line, saturated. Above the line is super saturated. Okay, there you go.